So here will appoint one person. Okay, now you'll hold one end of the rope, and what you'll do, you'll start waving his hand vertically up and down. So what we should ask him, okay, come on, move your hand up and down. Then what you see, you can see there will be a wave will be generated, and the wave will propagate like this. So when this will happen, when that person continuously, he should wave his hand up and down. So what is the care he has to take it? Tell me, like, to have the wave generated like this, what he should do? This is the amplitude, no? Tell me, and there is the frequency also. We have that one. So if amplitude, if I say 1 centimeter, what this person should do? He should move his hand up by 1 centimeter up, then 1 centimeter down. Like this only, you should move, no, up and down 1 centimeter, 1 centimeter. If he moves here 2 centimeter, 1 centimeter, yes, there'll be some sort of wave. What happened? The amplitude will not be same. Amplitude means the maximum displacement of it should not vary with the time. Amplitude is a fixed maximum displacement of particle from mean position. Already we know in SHM, we have discussed everything, that one. So these are the conditions for person. Again, what happened? In say like a 1 minute, he completes 20 to and fro motion. So then that will determine the time period. No? So 1 minute. So here what happened? 20 to and fro motions. Then can we calculate the time period? Time taken for 1 second, time taken to complete one to and fro motion. Shall we call that as a time period? What is the time taken to complete one? So 1 minute means like it's like a 60 seconds. I'll call it. For 60 seconds, 22 and fro motion. So for one to and fro motion, what's the time? Anybody value? Three seconds, shall I call? Time taken to complete 3 seconds. So what this person should do, we know time period. So from time period, what we can calculate the what you can call omega 2 pi by t. Then f equal to 1 by t. Okay, like this, we'll get the frequency. Amplitude, I'll say 2 centimeter. Okay, got this one. So now what's happened? We are asking the person in 1 second, in 3 seconds, he should complete one to and fro motion. He should complete means he should not jump. The person should move his arm up and down. I think you know, all of you English language. If I say person will wave his hand up and down means you should know. I'll be moving up and down. I'll just show in video. Some of you are having very poor knowledge of physical world. No, it'll be like this. Huh? I'll hold a rope. I'll move up and down like this. There's a mean waving his arm. It's not that he should jump up and down. So that is nothing. So it should be like this. Huh? You will wave his arm up and down like this. So in 3 seconds, it should move. So there's a reference. I'll take it. It'll be like this. Huh? So like this will happen. To complete this to and fro motion, what happen? I'll take 3 seconds. So that will determine the frequency of a wave. So what is this F now I should call? Frequency of a wave. And what is a amplitude? Who will determine amplitude? How much will wave is at up and down? Okay, got this one. So amplitude say 2 centimeter. Then like this, shall we ask the person to generate transverse wave for 1 hour? So for 1 hour continuously, he should wave his hand. That will happen. Strict condition. His arm should move up by 2 centimeter. Again should come down. Again 2 centimeter. Like that. Nowhere he should increase this distance to more than 2 or less than 2. At all the time, up 2 centimeter, down 2 centimeter from mean position. Then again continuously open for every 3 seconds, 1 to and fro motion. Possible. Anybody can do. Do it for, I think, 3 seconds. For 5 minutes, you do it. You'll get a pain. But as there is a wave, in what direction the wave will propagate now? The wave will propagate in this direction. What is V? V is the speed of wave. A is the amplitude of wave. What is the frequency of a wave? This is a one way of generating a transverse wave on a rope. How the points on a rope? They'll move up and down. We already know it. Okay, got this one.
Sir, how did you write A, sir?
Amplitude, I'll move up and down my arm.
Sir, how did you calculate it, sir?
Maximum displacement of a point on a rope from mean position. SHM idea, no? So I'll move up by 2 centimeter. Then I'll move down by 2 centimeter. So definitely what happened? This is the maximum displacement, no? Okay. Based on this, how much will move up and down, that much the points will move like this here. Okay, got this one. So now this is one way of generating a transverse on a rope. So I think the biggest problem is what? Maintaining the time period and maintaining the amplitude. So shall I go for an instrument? Yes, I do have an instrument. So here amplitude knob and the frequency knob. Two knobs are there. This I will electronic instrument it is. So there's a switchboard, there's a wire, no? It'll be connected and I'll get a rod. There's a rod. This is the very fundamental of our chapter. I don't know the in books it has missed it badly. There's a problem with our books. This is very, 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 very important. What all we discussed now, just the whole our chapter revolves around this diagram only. This is what we do in lab. Nobody will, no, no. I'm telling you, son. Nobody. What will happen will be. Let me take this. Nobody, no person will hold the rope at one end and will be start waving that one. Not possible to generate exactly transverse wave. Amplitude will be varying that one. So what is the practically? This is the instrument. This is called like a rod. This is a rod. This is a rope. And here is the wave is propagating. So when I switch on, this rod starts vibrating. It'll vibrate up and down. Then how to determine the amplitude? Amplitude not be there. I'll keep 2 centimeter. What happened to this particular end of the rod will move up by 2 centimeter, will move down by 2 centimeter. Maximum displacement of the rod. So how much this will have maximum displacement, that much will be the amplitude of a wave. Getting the idea? And this is the mean position for us. This is the mean position. So now this will become amplitude. Okay, that's an will determine amplitude. Yeah. No, I want 1 millimeter. 2 centimeter is very high. Usually it'll be millimeter, 1 millimeter, 2 millimeter. The rod will vibrate. That one. So it will vibrate up by 2 millimeter, 2 millimeter down. Then this will be the amplitude. So we'll determine amplitude of the wave now. The source here we have. Then here frequency. I want frequency of say like a 1/3 hertz. That one. Or 10 hertz. What do you mean by 10 hertz? What do you mean by 10 hertz? In 1 second, 10 oscillations it should complete as rod possible. No? I'll keep frequencies like a 2 hertz. In 1 second, two oscillations will be completed. Then the frequency of the wave will be the 2 hertz. So like that by rotating this knob, no, I can now generate a transverse wave of desired amplitude and frequency. Got the idea? This is called like a vibrator. This is called like a Medley's experiment. Type it. You have video also. You can watch it. Huh? This is what actually Actually, in a lab, we are supposed to do, but we don't do lab. That is what our education system. In fact, you just go to the lab, see once, no, this chapter will get over for you. But we don't want to learn in that way. How we want to learn? We want to learn only through book. And we'll write exam, we'll get a rank, and we'll become engineer without knowledge. That's what our trend, no? Okay, at least watch videos available. Huh? You are lucky enough to see this physically, at least through videos and graphics, everything. Okay, fine. So the amplitude as by rotating this knob, the frequency, and the disturbance will propagate towards right here. Got the idea, no? So what is the wave equation? What we have? Y equal to a sine omega t minus, oh sorry, this one. So this I will rewrite a sine omega t minus omega x by b. So this further minus kx. So what is k now? K is called as a propagation constant, not spring constant, huh? Or wave number, anything you can call propagation constant it is. So now we'll define the speed of the wave, velocity of wave. It is minus of coefficient of t by coefficient of x. Substitute them with sign. Then this is v bar is equal to a quotient of t. What is the quotient of t? Omega plus omega. Quotient of x, looking at this equation, quotient of x minus k. So this will become omega by k. So what do you mean by positive? The wave is propagating towards right. If you get V positive, the wave is propagating towards that. If you get V negative, the wave is propagating towards left. Like that, if they give wave equation, from that, what we can determine? The speed of a wave. What is V? Velocity of a wave or speed? Because I know it is moving towards right now, I can also call it the speed of the wave. The speed with which disturbance propagates, or the speed with which energy propagates. That's the meaning of this one. What is velocity of wave? Speed with which disturbance. This is also called as the wave speed. Both are same. Okay, fine. This called like a amplitude of a wave. Already I think I discussed this. What omega? What is omega? 2 pi, the frequency of a wave. So what all the wave will have? Amplitude, frequency. Okay, then next I'll go for wavelength, all other things. Okay, next what we'll write? F is equal to omega equal to 2 pi by t. So F equal to 1 by t and omega equal to 2 pi f. Then we know other side F equal to V by lambda. What is V? Speed of the wave. Lambda is the wavelength. F is the frequency. What is the V? V is the wave speed. For non-mechanical wave, this will become speed
Sir,
of light.
omega will be 2 pi into f, sir.
Okay, this one. Ma. Okay, thanks for correction. Yeah. So there's a frequency of wave equal to speed of the wave by wavelength of the wave, like this. We can write it. Okay, now further, what is F? F equal to 1 by t. I'll write it here. F equal to 1 by t. So therefore, what we can write it as now, lambda equal to v by t. So this is lambda is what we write it. And other side, we know how these things omega k are related. V further what we can write, omega by k. Omega is what? 2 pi by. Oh, this is. or k equal to 2 pi by lambda. These are all relations between the wavelength and the k. Wavelength and the k, that one. Now there are some definitions what you can put it here now. Okay, now I can write this in another form, the same wave equation. This, what is 2 pi or omega? 2 pi by capital T. This will be 2 pi by lambda into x. So these are the various forms in which we can express the wave equation. So what these are called as? Transverse wave equation. So now I think we are quite familiar. What is lambda? Lambda is the wavelength, T is the time period. So what do you mean by capital T? Time taken by the point on a rope to complete one oscillation. Simplest thing. What is the lambda? Distance between, no, I'll define this one. Distance between 2 points on a rope which will have same phase. Maximum displacement of point on a rope. Okay, what is y? The position of a point on a rope at any time t. Means a point on a rope, its vertical displacement at any time t. There's the meaning of this one. So this further, we will, this is a practice what, instead of writing only y, no, better make a practice of like this. So what is the meaning of these terms? Once again, I'm coming. A point vertical, let me put here, it will be vertical displacement of a point at time t. What is a maximum displacement of a point on a rope? What do you mean by capital T? Time taken by a point on a rope to complete one oscillation. To and from motion, I'll call oscillation. What is the lambda? Let me, I'll move down so that we'll express all the things. This is very important. Once we know this terminology, it'll be very easy for us. What is lambda? On a rope that will have same phase. Okay, we got everything. What do you mean by x and t? This is something very important. What do you mean by x? Position of a point on a rope. At what distance the point on a rope is from the origin? Position of a point on a rope. What do you mean by t? Instantaneous time. Okay, this is the core idea. All the terms is what I just put it. What is x? Okay, you are holding the rope at one end. Okay, some at 10 centimeter, or you picked up a point on a rope which is a distance 1 meter. So for x, what you write? You are going to write 1 meter. Current idea? So now, okay, let's explore further. We'll differentiate. We'll see what we'll get it. Because now we have generated a wave equation. So what is this? General wave. It's like a wave equation. So we are in one of the best position. Means as the wave propagates, we are able to find out the displacement of any point on a rope at a given time using this one. So let me differentiate this. So if I'll proceed like this. let me differentiate dy by dt. So a omega cos omega t minus k. So what is dy by dt? I'll call Vp. So what is this? Speed of a point on a rope. On a rope or a string? On a string. Now what is a omega? Maximum speed of a point on a rope. So this you can also write it as V max. Like in SHM, what we had, similar to that here. Okay, this colloquial speed of a point on a string will give one specific name. I'll call it as particle velocity. There are two things are there. Wave velocity, particle velocity. What do you mean by wave velocity? The speed with which the disturbance propagates. What is the particle velocity? The velocity of points on a rope. This still more better form. Or I'll write it so that you will not get confused. You'll start thinking two are different. So we can write. Okay, the person now, let me differentiate further. D square y by dt square minus a omega square sine of okay, this is a sine omega t. I can write it as this acceleration of particles. So look at how is acceleration? Anybody wants to comment on this? The last equation. How is the acceleration of point in a loop proportional to nature of displacement? Is it SHM? Yes. So therefore, what I can conclude, the points on a rope execute SHM. We have enough of mathematical ideas of SHM. No? So it'll be very easy for me to now to learn the transverse wave propagation on a string. So when a wave propagates on a rope, the points on a rope will execute SHM. This is the conclusion. The points on a rope execute SHM. Means, therefore, we will write like a theory, like a information. Therefore, when a wave propagates on a rope, the points on a rope execute SHM. Okay, there's a very, very, very important part. So you know all this mathematics, and if you don't know what is the meaning of this, it's of no use of learning. Means what actually here is a person holding one end of the rope as he starts moving his arm up and down. What happened to these points on a rope? They'll execute SHM and the energy will flow horizontally. This idea again and again, some 1 crore times you tell to yourself, you have to accept this 1 crore times, not another, because this is the thing over. We know all the mathematics of SHM. This chapter itself is over. You not to bother much. So when person holding one end of the rope, if he moves his arm up and down, that's all. The points on rope, they'll execute SHM. And what happened to energy? Because see, now you can ask questions from where energy you're talking, why you're talking energy? Anybody? You know enough mechanics now. I say that energy flows. From where that energy is coming? Anybody wants to answer this? I'm testing your physics now. What point you have to go to or no? Yes, yeah, you should answer. Anybody? I say that energy flows from where that energy is coming. Let it be right or wrong. Why you're bothered? Yes, anybody? Can you reply? Okay, you do one thing. After class, no, if you get a time, so that 5 meter rope, no, you tie to one end of the wall and move your arm for muscular energy. Okay, fine. From our body, muscular energy. That's what you move your arm for from the morning for 1 hour. You move it. What you feel pain in your arm, no, and you feel tired, no. Like this, I'll ask you to move your arm for 1 day without taking any food. You will become weak. So what does it mean? Where do your energy gone? You did work. What happened as you move your arm up and down? You are what happened generating a wave, and that energy is flowing on your. But sir, I am not seeing. Can you see? Not possible. No. What you can see only the points on a rope moving up and down. That's all, and the energy will be flowing on a rope. This is the idea. There's a major part of the discussion now. What we are doing. So as you move your arm up and down, your muscle energy, what happened, will be given to the rope, and the energy will flow on the rope. There's a beauty of physics here. No, like this, can we appoint a person to generate a wave? All technical problems are there. So let me go for this device, this vibrator. I'll switch on the button. Then the rod starts vibrating. Sir, how it is possible? We know mixer, everything, so many things are there. No. Similarly, here, what happened? The rod starts vibrating. The electrical energy will be converted into mechanical energy by this instrument. The rod vibrate. And the rod vibrates, the energy will flow on a rope. So what actually this instrument will do, will convert electrical energy into mechanical energy. And that mechanical energy will flow on a rope. And that's what we call wave energy. So there is a flow of energy on a rope. You tell this 1 crore times today. You hold a rope and you start moving like this. Oh, energy is flowing, energy is flowing. Points are moving up and down. Energy is flowing, energy is flowing. The speed with energy flow, that is the wave speed. Yes, this is what you tell to again and again. And again you ask, what are these, what are these, what are these? Digest it, and the points on the rope, they'll execute SHM. So now we learned two things, no? Wave speed and this particular thing. So let's do one thing. We have very good equations. Here d square y by dt square, we have one equation here. Instead of differentiating with respect to time, let me differentiate with respect to x. Then we'll see what equations will end up. Let me differentiate again. If I differentiate again, I'll get it as a k square let me take ratio of these two. D square y by dt square all divided by d square y by. Let's see, anything will get it. Okay, d square y by dt square omega square a sine. Okay, this is called as d square. This is called a general wave equation. Very, very important. If they give any mathematical equation and if they ask you, will it represent wave? What you should do? It should satisfy this equation. Second derivative of a function with respect to time by second derivative of a function with respect to position. If the ratio of that equal to square of wave speed, then that particular equation represents wave propagation. So that's why I use word general. Which wave mechanical wave, non-mechanical wave. This one, transverse wave, longitudinal wave, transverse mechanical wave, longitudinal mechanical wave, transverse non-mechanical, anything, the moment you say wave, then it must satisfy this one. This is what we'll call general wave equation. So they give some equation. Will it represent wave motion or not? Okay, put it here. The ratio of that should be equal to square of wave speed. Okay, fine, it represents wave equation. Otherwise, it will not represent wave equation. There's a general, I'm using word general. Is it understood now? It's not applicable only for transverse wave, for any wave. Okay, again, I'll go back to this. I'll take help of these two. So on one side, let's explore further. I'll differentiate already. We have dy by dx, no? So let me take this one. Minus ak cos omega t minus kx. I'll divide these two again. Vp by omega a what is omega by k? Should be v, no? So what is the equation, no? Vp equal to minus v. Anybody, can you say, what do you mean by dy by dx? What do you mean by dy by dx? Ah, okay, let's do one thing. What do you mean by Vp? Particle speed. What do you mean by V, capital V? Wave speed. So what I should I dy by dx? Slope. That's all, no? So that's why you look at, I define this is y and x. So I'll draw a tangent. What is a tangent? Tan theta dy by dx. So slope of a point on a rope. Simplest idea. This is, so dy by dx means what does it mean? Slope of a tangent drawn at a point on a rope. So with that, what happened? We can determine the wave speed also, all other things. Okay, now still many are having doubt. Sir, how do that wave propagates? How points will move? Okay, you are expressing all mathematically fine, very good. But still, how do that wave propagates? We are unable to say, okay, let's get into, now we have enough of formulas. What all we know? Points on a rope execute SHM. Yes, we are very sure, no? When a transverse wave propagates on a, when a disturbance propagates on a rope, points on rope will execute SHM. And what is capital T? We know time taken to complete one oscillation. What is the amplitude maximum distance to a point on a rope? Then next we have something, okay, this acceleration and the square of double derivative of y, they're related. This is a wave equation. Anyway, this is a mathematical one. Okay, now one more very important is what I have here. The speed of a point on a rope, the speed with which energy propagates are related to slope by this particular equation. Okay, now with all this background, we will enter into how in one, how that wave propagates this one. So I'll be